Hello and welcome to my crash course on system design. If you have been working for the same company for a couple of years, but now you find yourself back in the interview game, you might gonna face a challenge you didn't expect, the system design interview. And just like the regular coding interview, it's very likely that you're not being equipped with the skills you need to excel in that kind of interview just in your day-to-day work routine. And that's exactly why I'm recording this crash course, to get you a head start with this kind of interview. There's no pre-requirements and we're gonna start from scratch. I'm so looking forward to teach you everything I know about system design. We start off with the most common system component, the service. It plays a vital role in creating modular and scalable architectures. While it appears trivial at the first glance, it's worth taking a closer look, as using this basic component correctly is much more complex than you might think. Each of the following videos will be focused on a single system component, like databases, message queues, caches, and many more, till you have a solid understanding of the foundational building blocks of modern large-scale systems, just like the ones you will encounter in your system design interviews. Moreover, this series is really hands-on. That means you will also learn how to use those different components in architectural diagrams. If you are unsure whether the system design interview applies to you, I prepared a short quiz to help you determine that. It won't take longer than 30 seconds to answer, and you will also get a customized preparation roadmap tailored to your professional profile and the kind of companies you are interviewing with. You find the link to that quiz in the video description below. But now, let's get going. A service is a self-contained unit of functionality that provides specific capabilities or performs a specific task within a system. Besides business logic, each service has an interface, often referred to as API. It defines how other components or systems can interact with that service. By applying a service-oriented architecture, systems gain a couple of benefits. First, modularity and reusability. Services are modular and can be reused across components or systems, reducing duplication and promoting code reuse. Second, scalability. Each service can be independently scaled based on its specific needs, allowing the system to handle various loads effectively. Third, flexibility and agility. Services enable flexible development, as teams can work independently on different services without affecting each other. This promotes fast iteration and deployment. We start by drawing the first architecture diagram to better understand services. Imagine a simplified version of a shopping system like Amazon or Flipkart. Every system has a front-end application, for sure. In a system design interview scenario though, you don't pay much attention to it. More interesting are the core functionalities of the backend. And no matter how fancy you want to go with your architecture, at its core you always have three main services, such as the authentication service, the product category service, and the payment service. Let's go through each of them and find out what they do in detail. The authentication service is responsible for user authentication, ensuring secure access to the system. An action that looks as follows. When a user attempts to log in, the user interface sends a request to the authentication service with the user's credentials. The authentication service then verifies the provided credentials against its stored user data, such as username and password. If the credentials are valid, the authentication service generates a token known as the authentication token or session token and sends it back to the user interface as a response. This token then serves as a proof of the user's authentication. When the user searches for a product, the user interface sends a request to the product catalog service, specifying the search criteria. The product category service then queries its database, which contains information about various products. Once the product catalog service retrieves the relevant products based on the search criteria, it sends the list of products back to the user interface as a response. When users add products to their cart and proceed to checkout, the user interface sends a request to the payment service. The payment service securely handles the payment process by communicating with an external payment provider, such as PayPal or Stripe. It encrypts the payment details, authorizes the transaction, and ensures the secure transfer of funds between the user and the merchant. Oh, and by the way, if you want to create your own system design architecture diagrams, probably alongside this course, I recommend you using the free and open source drawing tool Excalidraw. And if you want, you can also use the custom components I use here, and you can find a download link for them in the video description below. So far, we have only seen Amazon's front end calling individual services. But what about inter-service communication? And this is a super critical aspect when you're designing large-scale systems, because services also need to communicate with each other in order to enable more complex workflows and to also deliver a seamless and comprehensive user experience. For this video, we're going to assume API calls are the only way services can communicate with each other. In a later video, we're going to come back to this assumption and learn about the drawbacks of this approach you should really know about. But for now, let's just go back to the drawing board and we're going to start designing an architecture for a streaming platform like Netflix in order to better understand why and how services would communicate with each other. Just like within our previous Amazon example, the user interface sends a request to the user service with the user's credentials. And the user service then authenticates these credentials by verifying them against its stored user data. Once that's done, the service retrieves the user's profile preference and viewing history from its database. And this makes the user service a very important, highly frequented resource for all kinds of services, which may need to access user-related information for personalization or recommendation purposes. Let's talk about one of such services that would fetch user-related data directly from the user service, the billing and payment service. Other than the payment service of Amazon, here the service would need to handle recurring payments as Netflix has a subscription model. So, when a user decides to upgrade their subscription plan or billing information, the user interface sends a request to the billing and payment service. Once the service retrieves this user request, it starts to interact with the user service by requesting relevant data such as payment details or subscription information. Then it would start communicating the new terms and conditions with the external payment provider and then update the user's payment details according to the confirmed changes. Another service which consumes user data is the recommendation service. As users watch movies and TV shows, the recommendation service continuously analyzes their viewing history and preference. Based on this analysis, it generates personalized content recommendations. The service utilizes machine learning algorithms to do so. To improve the quality of recommendations, the recommendation service might also want to use user-related information. Clearly, you want your algorithms to know which was the last movie a user watched before downgrading or canceling their subscription. To get access to such information, the service simply makes an API call to the user service. To be honest, the diagram got really messy, so let's clean it up. The arrows I drew were to visualize the data flow, but for the interview, I recommend you to draw way fewer arrows. You have very little time, to be honest, and that's why it's best you focus on indicating the user flow that matches the functional requirements you agreed on with your interviewer. This is so much better now. Let's add two more central services and think about their dependency on each other. Which ability could be more central to Netflix than streaming out videos? And this business logic is encapsulated in the video streaming service, which is responsible for providing the right chunk of video content to every user device which requests it. The service optimizes video quality, supports adaptive streaming, and ensures a smooth playback. When a user selects a movie or TV show to stream, the user interface sends a request to the video streaming service specifying the desired content. The video streaming service then retrieves the video file associated with the selected content and starts streaming it to the user's device. Because videos are streamed out by chunks of data, it makes sense to think about which kind of database would be most suitable for that use case. For now, it's good enough to acknowledge that the service would fetch the requested data from a database. In a service-oriented architecture, it's very common to have individual instances of databases for each service, and this helps to decouple them from each other. Having a single database being used by multiple services is somewhat of an anti-pattern. But for now, let's move on to the last service that is in scope for today. Now, the system is able to stream out video content, and that's great, but it's still worthless without a vast collection of movies and TV shows that users can choose from. And that's where the content catalog service comes in. It handles metadata, categorization, and search functionalities of all the available content. When a user searches for a specific movie or TV show, the user interface sends a request to the content catalog service specifying the search criteria. The service queries its database, which contains metadata about the available content, including titles, genre, actors, and descriptions. Once the service finds the relevant content based on the search criteria, it sends the list of matching movies or TV shows back to the user interface as a response. The user interface then displays the search results to the user. Other services, such as the recommendation service or the video streaming service, need access to content-related information or request specific content for streaming. They make API calls then to the content catalog service specifying the desired content or search criteria. I want you to be aware, we just used API calls as the most simple way services could communicate with each other. In real-world systems, typically you deploy additional system components like message queues or microservice orchestrators in order to decouple your services from each other. However, this is beyond of this lecture. We're going to talk about it in a future video, and in case you're watching this and the video isn't out yet, it's the perfect moment to remind you to hit that subscribe button so you're being notified whenever this video comes out. Now let me wrap up and define some clear takeaways for you. Services are the most common system component and form the foundation of modern large-scale systems. A service is a self-contained unit of functionality with an API interface that allows other components to interact with it. Modularizing your business logic via service-oriented architectures provides several benefits as you can scale deployment and development alike. Typically, each service has its own database. Inter-service communication is a critical aspect in any large-scale system because it enables complex workflows. Real-world system designs may include additional components such as message queues or microservice orchestrators to decouple services from each other. And now I'm asking you, what do you think are the most critical services for a system like Netflix? And how would they communicate with each other given the constraints that they can only call each other's APIs? Let me know in the comments below. Thank you so much for watching this video till the end. I really hope you enjoyed it. If you want to accelerate your system design interview preparation, I do have an online course which dives deep onto the topic. You'll find a link to it right here, and that link always going to provide you the best price available for your region. So see you in the next video or in the online course, as you like. I'm always happy to help you prepare for your interviews.